Hello, Elena. So I hope things are going well with the baby and with your cousin and your family. So come back and tell us all about it. We are going to gather here in this little corner, as we like to do, the things that we learned yesterday. So would you open your notes to, what was that, day la 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 la?
Day
Six?
yesterday.
Day la 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 6, was it? Do you have that one?
Chapter 6, Jake.
Was it 6-6? Were you here yesterday, Brandon?
Yes.
Pardon?
Yes.
Yeah, so do you have your day 6 notes? It was given out yesterday. The one with the glass of water on it. Do you have that one? Okay. All right, we're going to gather in this corner some of the things that we have gotten from that. So if I throw out a question, not a question, but a concept, can you complete it for me? First of all, the important thing is we found the mean of a binomial. I'll use subscript b to indicate that it's a binomial. Can you look over your notes? What was the mean of a binomial distribution?
N times P.
Thank you, Allie. N times p. All right, so Bailey, do standard deviation from yesterday of a
Square root of NP times something minus 1, I don't
1
remember.
minus P.
1 minus P.
okay. So we have a success, a p here, and a failure. So they kind of get grouped together a lot. So, and standard deviation is always a square root. If you're aiming for the AP test, these kind of things will have to be committed to memory. They do not let you take in an answer, crib sheet. So, a cheat sheet. All right. So then I think we finished yesterday by describing that we can assume that a random variable that is binomial, a binomial distribution can be considered normal for large N. And how, could you check your notes or your brain, Caleb, and tell me how large is N? How do we decide for N large? For large N, but we had an idea of how large. What did we say?
I don't.
Did you write that down?
I wrote that down.
Okay, give him a moment. No, it's not there? All right, make sure it is. And Julia, fill us in.
NP is greater than or equal to 10,
Uh-huh.
and then N in parentheses 1 minus P is greater than or equal to
Right.
10.
All right. So that is like the expected value for success and the expected value for failure have to both be greater than 10. So these are the three things that I noticed from yesterday. So there's one more thing to finish, so I'll finish that and then we'll look at the assignment and then do our last day's work on this mod. So, all right, would you look at the shopping example? It's on the back. Brandon, would you read it to us about where it talks about attitudes towards shopping?
Attitudes towards shopping. Normal approximation to a binomial. Sample surveys show that fewer people enjoy shopping than in the past. A survey asked a nationwide
Somebody over there.
nationwide random sample of 2,500 adults if they agree or disagree that I like buying new clothes. But shopping is often frustrating and time consuming. The population that the poll wants to draw conclusions about is all U.S. residents aged 18 and over. You get a phone?
All right, so let's see. Let's see if I had any comments before that. Go ahead and read the problem. What's the first one?
Suppose that exactly 68% of all adult U.S. residents would say agree if asked the same question. Let X equal the number in the sample who agree.
All right, so we're looking, they took a survey, and a sample of that was 2,500 adults and from all of the United States. So they want to know, do you agree with that statement that I like buying stuff, but it's kind of a pain to buy stuff? So,
Is it buying stuff like physically going somewhere to buy
Yeah.
stuff, or just buying stuff?
yeah, I think it's because the picture looks like she's at the store. He's at the store.
Yeah,
Sorry, I
he-
can't tell if it's a boy or a girl, you know. Whatever. So,
It does.
so the actual process of going out shopping, people don't like that so much anymore. So we've got 60% people in the United States, adults anyway, agree with that statement. Show that X is approximately a binomial random variable. So let's do our bins. So starting with B, Allie, is it binary?
Yes.
So either you agree with the statement or you disagree. All right. Bailey, is it an independent, if I have an answer, is it independent from the next guy's answer?
Yeah.
Okay. Is the number set, Caleb?
Yes.
And what was the number again?
2,500.
Okay, so number was set, I'll put it up here, we'll need it in a second. And Julia, is the percentage the same, is the probability the same for each trial?
Yeah.
All right, and what was it again?
60%.
All right, 60% agree. All right, so with that, go on and Brandon read question 2. So we agree it is a binomial. All right. Question B, sorry.
Check the conditions for using a normal approximation in this study.
All right, so can we jump over and use chart A, which indicates that this is not just a binomial, but it also shows the normal distribution, the bell-shaped curve. So throw this information into these test points. So tell me what comes out. So you're going to try to see if the number of trials times the probability of success, NP, is greater than or equal to 10. Then you're going to put in n times the probability of 1 minus p and see if that's greater than or equal to 10. By a lot? Is that right?
Yeah, by a lot.
All right. So what is the probability, not probability, what is n times p in this case?
1,500.
All right. So is 1,500 greater than 10?
Yep.
All right. Okay. All right, so checking the number line, I see there's quite a difference. What about n times 1 minus p? Bailey, give me that number.
1,000.
That one's a little more,
Yeah, it'd be 2,500 times 0.40. Negative 3,000.
what is it?
2,500 times 0.50 gives you 1,000. 0.40 gives you 1,000.
0.4, right, so what is it?
1,000.
1,000, sorry, I didn't hear you.
Okay.
So 1,000, so is that bigger than 10? A lot of the problems you'll see are not even near 10, so they're so clearly, the normal approximation is such a good approximation, we go with it. And we're gonna go with it.
9.99.
I'm sorry?
But if they're like 9.9 and they were not up to 10,
Yeah.
would they still be considered?
Yeah, I think I would use it, but with reservation. Okay, Brandon, would you read the next one?
Yes, ma'am. Use a normal distribution to estimate the probability that 1,520 or more of the sample agree.
All right, so now we're in, we're gonna use back to mod, whatever, chapter 3 or wherever. We learned how to use this in the normal distribution. So we have to normalize or standardize the curve. So we have to take this number, subtract the mean from it, and divide it by the standard deviation. So to get me to that point, Caleb, would you please find the mean for this population? We actually did it without trying already, so I'll grab that one and you can help me with the standard deviation, Caleb. So the mean is NP, and we had to also use NP for that test, so I'll just grab that number, 1,500. So Caleb, I need you to use this formula right here to find the standard deviation. Tap that in and tell me what you get.
Would be, square root.
Yeah, there's square root involved.
1,224.7.
That high? I I got something like,
I got 31.6.
I got 24.5.
Oh, wait, never mind, I thought, I saw the 1500 and the 1000.
So it's 2500 is the population number. Oh, where is it? NP is 0.6 and 1 minus P is 0.4. Did I do it wrong? I got
Right,
24.
You did it right. Wait, no, it's the
24, yeah, you're right.
Alright. You got it, Bailey? What happened? Here, did you put these numbers in?
me.
Yeah, you got 31, or somebody did. Oh,
I
Ally?
put in the numbers they gave us, like we found in the thing.
Okay, so it's these numbers.
Yeah.
That's all right, 24.5. All right, a Z-score. So, Julia, tap this into your number, in your calculator, and give me the Z number. And then, Brandon, I'm gonna ask you to look it up so you can find your chart A. Chart A in the back. Oh, you got that one, that's even better.
Right. No, 150. It's minus 150 or
1500. You didn't
Oh,
put
did
the
I
zero.
forget the zero? Oops, sorry. Did you see that, Julia? That's gonna
Um,
change your work a little bit.
I just saw it. I
I'm
got
sorry.
0.816.
0.8, well, I'll do 0.82. I think that's all the
Okay.
chart will take.
Right.
All right, so Brandon, look up on the chart the Z-score of 0.82, and we're expecting the normalized numbers on the curve start with 0 and then they go up to 1 and down to -1. We're looking at 0.82. So what the chart is going to give us is everything to the left of this line, and that number is, Julia?
From the Z-score?
Do you understand?
Yes.
Hold on.
You see what she drew?
Oh, no, not you, Brandon.
Yeah, yeah.
Sorry.
Okay. I can
0.799.
0.79, what?
39.
All right. So that's 79.39%. And notice that will give us everything below. So this problem asks for everything above. So Ally, what is my final step to find this problem?
1 minus.
Right.
Wait.
Yeah, so what do you get?
And you would get
0.206.
All right.
1.
All right, so 20, almost 21%. All right. So that's how we would do that, assuming, but we can't use this chart A business unless it's normal. So it has to pass this test, which it passed with way flying colors. So, all right. We didn't get to do that yesterday. We're gonna end. Do you have any room to take more notes?
Yeah.
All right, so find a little spot on the back. There's one more concept before we break and look at our homework. Do you remember what time we started taping?
No.
Maybe what, 7, 8 minutes maybe? Let's be generous and say 10. So when it gets to almost 5 up, we'll turn it up. Oh, that's right, we gotta, just 2 minutes. Why don't we shut it down now and we'll start the next problem? I don't care.